Hello everyone, I am Anjali Brahmane, Faculty of Civil Engineering Department from Vishwabharati Academy's College of Engineering, Ahilyanagar. Here I am representing online lecture series for fluid mechanics subject. Today's topic is properties of fluid and fluid statics. Now we will see the definition of fluid mechanics. Fluid mechanics is a study of behavior of fluids, that is liquid or gases, that are either at rest or in motion. This branch of science which deals with the static, kinematics and dynamic aspect of fluids. Next, application. First, civil engineering. Design, drainage channel, water network, sewer systems, water resistant structures and high-rise structure are the application of civil engineering. It's classification of fluid mechanics. There are three classification of fluid mechanics. First, fluid statics. Second, fluid kinematics. And third, fluid dynamics. First, fluid statics, the study of fluid at rest. And fluid kinematics, the study of fluid in motion where pressure forces are not considered. Last one, fluid dynamics, the study of fluid in motion where pressure forces are considered. Next, physical properties of fluid. There are 8 physical properties of fluid. First, density or mass density. Second, specific weight or weight density. Third, specific volume. Fourth, specific gravity. Fifth, viscosity. Sixth, compressibility. Seven, cohesion. Eight, adhesion. Now, first, density or mass density. Definition of density is mass density of a fluid is defined as the ratio of mass of fluid to its volume. The density is denoted by rho. Density of fluid decreases with increases in temperature. It increases with increase in pressure. The unit of density is kg per meter cube. Next, density of various material. Various material in table form. First material, second density is kg per meter cube, and third notes. First hydrogen density is 0.0898. Air material air density is 1.229 at sea level, and wood density of wood is 700. Density of water is 1000 kg per meter cube. Next, second, specific weight or weight density. Definition of weight density is, it is defined as the ratio between the weight of a fluid to its volume. Specific weight is denoted by W and its unit is Newton per meter cube. Third, specific volume. The specific volume may be defined as volume per unit mass of a fluid is called the specific volume. It is unit of specific volume is meter cube per kg. Specific volume is a reciprocal of mass density, and this term commonly applied for gases. Next, fourth is specific gravity or relative density. Definition of specific gravity is ratio of weight density of a fluid to its weight density of a standard fluid is called as specific gravity. For liquid, water, and for gases here. For example, if specific gravity of a mercury is 13.6. Next, viscosity or dynamic viscosity. Definition of viscosity is, it is defined as the resistance offered to a layer of a fluid when it moves over another layer of fluid. Now see in figure, water has low viscosity and syrup has high viscosity. Next, viscosity or dynamic viscosity. Let two layers of a fluid at a distance divide apart move one over the other at different velocity. Say u and u plus du as shown in figure. The viscosity together with relative velocities causes a shear stress on a fluid layers. The rate of shear stress is directly proportional to the rate of change of velocity with respect to y. Next, kinematic viscosity. It is defined as the ratio between the dynamic viscosity and density of fluid. Next, Newton's law of viscosity. It states that the shear stress in a flowing fluid is directly proportional to the rate of shear strength and significance of Newton's law of viscosity. The fluids which follows Newton's law of viscosity are called as Newtonian fluids. The viscosity of liquid decreases with increase of temperature, while viscosity of gases increase with increase in temperature. Next, compressibility. It is frictional changes in volume per unit increase in pressure. It is a measure of elasticity in fluids. The fluids are compressed under pressure due to change in their mass density. The liquid are generally considered to be incompressible because the pressure of 1,13,078 will cause a given volume of water to decreases by only 5% from its volume at atmospheric pressure. Next, cohesion. Cohesion is defined as the internal molecular attraction between the molecules of same liquid. The property of cohesion enables a liquid to resist tensile stress, and the cohesion is the property of like molecules of the same substance to stick to each other due to mutual attraction. Now see in figure. Last, adhesion. Adhesion is defined as the forces of attraction between the molecules of liquid and molecules of solid boundary surface in contact with the liquid. The properties of adhesion enables a liquid to stick to another body. Next, classification of fluids. There are 8 classification. First, ideal fluid. Second, real fluid. Third, Newtonian fluid. Fourth, non-Newtonian fluid. Fifth, ideal plastic fluid. Sixth, thixotrophic fluid. 7, pseudoplastic fluid. 8, dilatant fluid. Now, first, ideal fluid. A fluid which is incompressible and is having no viscosity is known as an ideal fluid. Next, real fluid. A fluid in which viscosity is present, that fluid is called as real fluid. All the fluid in actual practice are a real fluid. Some example of real fluids are first water, kerosene, petrol, castor oil. Next, Newtonian fluid. The fluids which follows Newton's law of viscosity are called as Newtonian fluid. And the shear stress in a following fluid is directly proportional to the rate of shear strain. Some example of Newtonian fluids are simple liquids like water, ethyl alcohol, benzene, and simple gases like air. Next, non-Newtonian fluids. The fluids which does not follow Newton's law of viscosity are called as non-Newtonian fluid. The shear stress in the following fluids is not directly proportional to the rate of shear strains. Now, some example of non-Newtonian fluid. Ketchup, lubricant oil, toothpaste, starch, blood, shampoo, and slurries are non-Newtonian fluids example. Next, ideal plastic fluid. The fluid which possesses a definite yield stress, but then the relationships between shear stress and angular deformation is linear is called as ideal plastic fluid. And it behaves as a rigid body at low stresses, but flow as a viscous fluid at high stresses. Now some example, first toothpaste, sewage sludge, oil paint, jellies. Next, thixotrophic fluid. The fluid which possesses a definite yield stress, but then the relationship between shear stress and angular deformation is non-linear is called as thixotrophic fluid. Some examples, printer ink and lipstick. Next, pseudoplastic fluid, a fluid in which the apparent viscosity decreases with the increasing deformation rate is called as pseudoplastic fluid. Some example, mud, polymer solution, milk, blood, and paper pulp in water. Now see in figure. Next, dilatant fluid. The fluid in which the apparent viscosity increases with the increasing deformation rate is called as dilatant fluid. Examples are dilatant fluids are suspension of sand, starch, butter, sugar solution. Thank you.